Everyone, we're going to take just a couple minutes to let people join. I'm going to manage my windows. Welcome, welcome, welcome. We'll get going here in just a moment. So I'm a little late. I was like, oh, I could update OBS. Why not? I had like my USB bus restart, and so I was like, man, maybe I should do a computer restart. And if I'm going to do a computer restart, I might as well do an update 20 minutes before I stream. You know, no big deal. Sounds great. Thank you, DCD. Hello, Sam. Twitch is live. Hi, Beata. Thanks for joining me. I'm going to hand lotion up a little bit. How's everyone doing on this Friday? This is like a super Friday for me because I'm taking next week off. I'm doing a road trip with my dad, which I'm very excited about. And I am hoping to work on the build system stuff while we're on it, but we'll see. All right, I think we're ready. So let me do the intro here. So hello, everyone. My name is Scott. I go by Tan Newt online. I smashed it as all one word, which I kind of regret doing, but it's too late now. It was randomly generated in like 1999. It's nice and unique. You can find me on all the platforms for there. This is Deep Dive, so it's a stream that I usually do, although Tim Foamy Guy, who will fill in next week for me because I'm out. And generally, if I'm out, Tim will do deep dives for me in this spot as well. So 2 p.m. Pacific till about 4 p.m. Pacific, we'll kind of talk about whatever I've been working on in CircuitPython. So CircuitPython is a version of Python designed for little tiny computers called microcontrollers. For example, this board here has a little computer underneath this canister or whatever that can talk to the Wi-Fi. This is a Wi-Fi antenna. This is an S2, so it doesn't have BLE. But CircuitPython runs on here. You plug in here, you get a CircuitPy drive, edit your code, and hit save, and it'll rerun automatically for you. I'm funded by Adafruit, so I contract for Adafruit. Adafruit makes devices like this. So this is a printed circuit board, and it's got the microcontroller on it and then some other goodies on it, and is in a particular form factor. Adafruit teaches you how to build that and do all sorts of different projects. So if you want to support me, I'm on the Adafruit channel. I'm funded by Adafruit. Go to adafruit.com and purchase something there. So that's CircuitPython, that's Adafruit. If you, there's 2 chats over here. Oh, and I got the direction right. This middle one is Discord, so if you want to join us on the Discord server, that doesn't go away as the like chat streams do. You can do that by going to the URL adafru.it/discord. We'll get you there. We hang out there. We do CircuitPython development in the open there as well. So if you want to see all things Adafruit, all things CircuitPython, that's the place to be. Hello to Tyeth and hello to Mark. Beata says Friday's been at least vaguely productive, which is good. Tyeth says, well done on the risky update. Which maybe you mean RISC 5 update? Is the USB host active on the S2 Feather? Oh, the Max 3421? It should be. It should be available on there, I think, but I could double check. Hello to Sam. Hello to Love the Factory as well. Mark said, I had a day with no meetings that turned into only 3 meetings, so not that bad of a day. Yeah. Well, I'm just going to, like, put time on your... I was listening to an Ezra Klein podcast, I think it was one. Why do people say that they're going to put time on your calendar when they're, like, taking time away from you, right? Like, when they say put time on your calendar, they mean, like, take your time to do a meeting, which I think is a funny thing. USB host active. We could check. Will CircuitPython.org tell us? Probably not, because it's only an absolute latest. We can double check. 4 megs flash. This is for 904, and this is for 9.1 beta. But I don't know. The other place to look is in here. Oh, the risky OBS update. Oh, yeah. Yeah. I got lucky. But, you know, we're pretty fast and loose here when it comes to this stream, so it wouldn't be the first time I've started late if I was trying to figure out how to fix it. But one thing I know that I think has hosed me before is if I do a partial update but don't, like, I have OBS Studio browser variant, and that is, that kind of needs to be recompiled every time you update Qt and stuff. So I know that I don't want to do, if I'm going to do an update, I have to update everything to make sure I'm not, OBS isn't linked against libraries that I've just replaced. Beata says, do you have a BLE getting started that uses Mac or BlueZ for central rather than Bluefruit app on a phone? I don't think so. I don't think so, but it should, if you're using the Chrome, if you're using Chrome to do it from code.circuitpython.org, then you should be able to just use like your OS to do the pairing and bonding, and then Chrome should be able to see it, I think, from there. But I don't know of a BLE getting started. You know, I think I did turn it on S2 explicitly. We could just try it as well. I think it is ports Espressif mpconfigport. Yeah, I mean, we need to do a better job of documenting all the BLE stuff. So it's on by default. It gets turned off on H2. It gets turned off, and that's it. It gets turned off on H2. So it, in theory, should be on for everything else. I don't remember. Sam J from Ohio says, so I love discussions about the ESP32 series and Bluetooth connections. Does this cover the ability to connect a Bluetooth keyboard with an ESP32, or is that something different? I know this is why I do hardwired HID keyboards. So, Sam, you need to clarify a bit. Do you mean having the ESP act to your computer like a keyboard, or having a separate BLE keyboard connecting to your ESP? Which are you referring to? And I know if you're watching on YouTube, there is quite a delay. Oh, you can't see my screen. Yeah. Sorry. There's my screen. I always do that. So this is what I was looking at. In ports Espressif mpconfigport .mk. So CircuitPy Max 3421E is, so the question mark equals kind of makes it as a default. So it's default on, and then I did a search, and the only other place that it is on this ESP32H2 has it off. And I'm not sure why it's off. It's probably size, and I'm tweaking some of that stuff too. I'm working, I don't see Sam getting back to me, but maybe I'll wait a little while longer before, because I know the round trip was pretty brutal. Let me get my setup going. Oh, so what am I talking about today? So the title says it all kind of, is I've been working on BLE GATT server support, which is like this like piece of Bluetooth BLE support. And we have a pretty good guide, and maybe it's worth covering. But the gist of it, okay, Sam's getting back. Yeah, let me get my compiling going, because I just restarted my computer, so I've got to do all this stuff again. And I just fixed a bug. How does that play out when importing usb.core? Does one get something equivalent from a Max3421E library? I was having this discussion, I think, with Justin, and it is weird. And it's weird in that you import Max, and then you construct the Max object, and then you basically don't seem to use it after that. You just use usb.core. And that's weird, and I feel like I should not do that. It's true for USB host as well. So if you're using native USB host, what you do is you import USB host, you do USB_host dot whatever it is, and then you just like kind of don't seemingly use that as well. So Sam says, to clarify, can an ESP32 pair with a Bluetooth keyboard and receive input? Example, if you press A, it does an event. I think so. I think that is existing. So let's talk BLE terminology, because the BLE terminology is really kind of crazy. And I think we do have a decent reference somewhere in our Learn guides about BLE. It's probably called Bluetooth Low Energy. Is it here? Understanding BLE. Okay, yeah, this is pretty good. Okay, so let me drop this link in the chat so folks can follow along. Okay, so when it comes to Bluetooth, BLE is Bluetooth Low Energy. There's an older version of Bluetooth that is not low energy, which I think you see as like BR or something. Yeah, USB host RP2040, and now swapping to USB host Featherwing ESP. Yeah, so you replace the USB_ stuff with the Max or the Max stuff instead. And then the USB.core stuff should work just the same. And it's the same as PyUSB. Okay, so when it comes to Bluetooth, there's kind of two main parts of it. There's GAP and GATT. GAP is this like, how do I discover the devices around me, and how do I initiate connections and kind of maintain connections? And then GATT is this thing of like, okay, once I'm connected, how do I discover how do I present capabilities to the other device, and how do I see what capabilities the device I'm connected to has? So that's the like kind of like very two high level bins. And then, and this has a good illustration of that. And then there's, there's even more terms in this. So, there's device roles, so kind of like what the device is doing currently. And the terms that aren't here are, like this has the term advertising. So, yeah, and we collapsed these two things. So they love their names. And I think like it makes sense to me why they have all these names, but they are not simple. Or like there's a lot of terminology that you need to learn to kind of like fully understand it. So Bluetooth low energy devices, they can advertise. So that is just like broadcasting a packet that maybe everyone else can hear. There's ways of like encrypting it so only one person pays attention. But generally, advertising is just like unencrypted, saying like very briefly, like here's what my name is. And if you've ever like opened a BLE settings or connectivity thing, you'll see like all this list of all the devices around you, like your TV, your like HomePod Mini, like all sorts of things you didn't think were broadcasting are broadcasting all the time. And that is actually the terminology that's not here, is that they have when it comes to the function of advertising, there's two roles that they define, if I remember right. One is broadcaster, so the person that is sending out the advertisements, and then there is observer. So the observer is the device that is listening for advertisements and doing that. So in CircuitPython, the adapter class, yeah, I don't know if we've talked about this on the deep dive, or at least not recently. So it's probably just worth talking over briefly. So we have this underscore BLEIO, and it's underscore because we actually don't really want people to use this version of it. We have a kind of higher level BLE library. Yeah, Beata says 873 devices that don't even broadcast a name, which it's allowed to do. Yeah, it could be that if you're trying to broadcast privately, you rotate kind of how you look. So it's probably not 873 devices. It's probably like, a couple dozen devices, and then a number of those are like quickly switching to looking like a different device instead. So if you're doing BLE, you're going to use this higher level Adafruit CircuitPython BLE library usually. But let's talk over it from here. So generally you have an adapter. So if it's built in, you just do BLEIO's underscore lowercase adapter. Generally you don't construct it yourself. It's constructed for you. It's like built into the chip in the ESP case for sure. And then you can see whether you're advertising, you can see whether you're enabled and active connections and stuff. But when it comes to being like the observer or advertiser or broadcaster, so you have this start advertising thing, and then you can stop advertising, and then you can, so that's how to start broadcasting, and then you can scan as well to observe the broadcasts that are going, the advertising that's going on around you. So that's like the basics of just like, I just want to broadcast some packets. And then the next phase is like, okay, I want to switch from this like unconnected state to this connected state. And that's when we have these device roles of peripheral and central. And most CircuitPython things can actually be both. But these terms are used to define who is initiating the connection. So the central is the one that is initiating the connection, and to the peripheral. So that's kind of on the connected side. And then during that connection phase, there may also be some security negotiations that happen so that the connection after that point is actually secure, or tries to be secure. So if you've ever seen like pairing codes or things like that, that's the process of pairing. Can I up my mic volume? Yes, I can a little bit. Is it quiet to other folks? I do have it like right here, so it shouldn't be too bad. Hopefully that's a little bit better. And sorry, I do have a fan on because it's 78 in here. And I switched to shorts as well. So pairing is the process of taking an insecure connection, kind of upgrading it to something more secure. Kevin says loud and clear. Thank you. And then there's this like one last process, which is called bonding. And bonding is the process of the peripheral. I think it's usually the peripheral. The central probably does some stuff too, but they basically save some information so that they can kind of automatically get back to that bonded state without user intervention the next time that devices connect. Because BLE is very much designed for the like, at any point, my devices are going to walk away from each other and they can't talk, or something's going to happen so they can't talk, and I need to reestablish that connection. So bonding is the process of basically saving the information for pairing. If you didn't save it, then you would have to do the like pairing process every time. So that is how you discover BLE devices and how you could get them connected. And then once they're connected, there's this separate thing called GATT. And this is where people get a little bit confused, understandably so, where separate of whether someone's a central or peripheral, you can also be a server or a client of a particular service. My volume is around 70% or so of other YouTube videos. Yeah, I don't have a compressor. In OBS, I'm getting into like the yellow, so I don't think it's too bad. So yeah, I'm not super fancy in terms of like getting my audio like super loud, super compressed. So in GATT mode, so the state of ESP support right now is that we don't do pairing and bonding, but we do, I think we do scanning and advertising, and we do connections. So we can do all that. That's been true for a long time. But what we couldn't do is this GATT server role. So GATT client can, if you connect to like a temperature sensor and it has a server for a temperature service or whatever, then you can connect to it and read the temperature just fine. But you can't kind of provide stuff yourself by being a server. And this was hung up for a while. Yeah, and this has the note that like a device can do both. So for example, like my watch is running CircuitPython and it's connected to my phone. So my phone is the central in this case, and my watch is the peripheral. But my watch is actually talking to BLE servers on my phone for notification information and time information. So I think one place people get a lot confused terminology-wise is mixing up central and peripheral with server and client. So central and peripheral is about who initiated the connection. Server and client are about who provides a given service. So a service is, and sometimes I mix server and service, but a service defines data, kind of. So this has examples of like, you can have device information service, you can have heart rate service, and then talking about USB keyboards, you can also have a human interface device service. A service is made up of characteristics. So a service is a collection of characteristics, and then characteristics can actually have descriptors to find out and have meta information about characteristics. So the thing that what we could do previously in CircuitPython is that we could connect and discover. So there's also a discovery process for like, hey, now that we're connected, what services or servers do you have? So I would think of it as like, what services do you provide? But it's providing them by being the server for those services. Like I said, it's a lot of terminology. And if folks have questions, I should reiterate, I'm happy to answer them. I'm happy to go on tangents as well. So servers, so we could connect to other servers on services on the other device that we're talking to. But for a long time, the ESP, the Bluetooth stack that it had expected you to say what services you wanted to serve before you did the gap like connection process, which is fine if you're like a fixed device where you're just the temperature sensor and you don't care who's connected or what's running. You're always just going to be a temperature sensor. You can compile it straight in. That's just fine. But with CircuitPython, and this is something we run up against a lot, I've been saying this a lot recently, we're much more dynamic in how we operate because we don't know what user code is going to do. Sorry for the, I don't know if you can hear the fire extinguisher venting outside the window. I don't know if you can see it on the window cam. Not quite. I think I've shown it before. So out my window is a fire extinguisher place, and every so often they'll, maybe I should just make window cam look that way automatically. Let's see if I can do that. There we go. There. Well, and go. Very loud. Sorry about that. Yeah, so that's what we can use window cam for. So yeah, previously in the IDF, you had to like know upfront what your services that you were going to serve are before you even allow connections to come in. But the BLE spec allows you to change services that you serve dynamically. And so in IDF 5.1.2, they added that ability to do that on ESP chips, which was like a huge blocker for us, because what we do is we kind of don't care whether a connection's going or not. We'll just create a service if we want to. So, you know, we'll use it for the BLE workflow services. So we have two services that we have by default for CircuitPython. One is a file transfer service. One is a serial connection service, basically. And then the user can also construct services dynamically from their code to serve. So I've been trying to get that all working on ESP. Now, if you are somebody who wants to have your ESP act like a keyboard, usually your central will also want you to pair and bond before you do that, so that you're like not sending keystrokes unencrypted. And that is not something that we currently support. That's something to do later when I get back. Hi, HamsLab. I'm late today due to a nap. Well, welcome anyway. DCC. So how does that dynamic services cause issues to CircuitPython? So the lack of dynamic services was a blocker for CircuitPython. So we start the Bluetooth stack up earlier than when user code runs to define the services that that user code wants to present. Did you get an insurance reduction for your remote office because the risk of inability to extinguish a fire is much lower than it is in another location? Not that I know of. Not that I know of. But yes, there is like a fire extinguisher place just right next to our building. So they should be well prepared. We're also like within a block or 2 blocks of like a fire station. Okay, so let me show you what I've been working on. So I did go on a little bit of a tangent, as I do. Let me switch to the camera so I can show you this board. So this board, I'll even go to product showcase mode. This is another dev board that I got. I talked about it, I think, last time from DigiKey. It's the ESP 8684, also known as the ESP32C2. So we have C3 and C6 support in CircuitPython, but we did not have C2 support. And so when I was sick of debugging BLE stuff, I was like, I'm just going to add this. And this has Bluetooth support as well, so I was testing it on that. And I actually just fixed a bug about fixed a bug where if you try to start BLE up but it doesn't have enough memory, it wasn't like correctly releasing all the memory back. Scott on YouTube asks, is the lack of consistent Bluetooth reliability due to how complex it is and the protocol has gray areas in its specs? Probably. a lot of the stuff that I actually interface with that has reliability issues is like classic Bluetooth, not Bluetooth Low Energy. But yeah, I do have like crashes on my watch as well. Like and it was like, yeah, it's weird. It's kind of like networking. Like it's not simple. You have to handle a lot of weird, like at any point when you're doing like a characteristic read, you could just lose connectivity and you have to deal with that. So it's, yeah, just like any networking code, it's really like you have to be very defensive in terms of errors and error handling and stuff to get it to be reliable. So it's tricky for sure. Okay, so I have the C2. It is working-ish. And actually, I've turned off. So one weird thing about the C2, oh, desktop again, is the ROM starts up, and I suspect the divisor is, it can either have a 26 megahertz or 40 megahertz crystal, and the board I have has a 26, so I think that's where this weird baud rate comes in, is it's like 74K baud rate, which I assume is like 115/200 times 26 over 40. So in order to see the output there, you have to do that. And I will hit the reset button. So this is all just my debug stuff. And I'm getting on the Wi-Fi. So the Wi-Fi stuff works, but the Bluetooth, when Nimble's trying to start up, when I do import BLE IO, it doesn't actually work. So if I just reset, so this is the web workflow. So I don't actually have any USB serial workflow. And I was just thinking I should try to fix this. So this is an escape code that was added after this serial terminal was added. So it's like a line clear. But here I can hit Control D, and now we see that we're getting an error. But a thing that I just fixed was that I couldn't do this multiple times. Like right now I can do it again and again, and it works just fine. But it wasn't working repeatedly because there was some function call that was erroring out on the IDF side, but as it errored, I'll just show you. Okay, so this is a function that we call from CircuitPython. Oh, and I'll tell you, I've been doing so much debug printing that like the copilot, the GitHub copilot integration, so helpful for just adding debug prints. It's like, yeah, quite cool. It's not always spot on, but it can be pretty helpful for like, I don't really care what I print out at this point, but I want to print something useful. It's like been really nice for that. So this nimble port init is what it was failing. So it did the controller init, it worked. It did the controller enable and worked. But then this ESP nimble init was failing, and I had to add this chunk. So the nimble init would fail, but it would not de-init the controller. And so you'd actually have less free memory because you tried to start it up, but it didn't start everything up correctly. This is like classic vendor SDK problems that CircuitPython has, where we're just running into things that like typically you don't hit because we're just more dynamic. So let me just see if I can say like ESP log, and you see there's this. I'm pointing to my screen, but on the left-hand side, there's an autocomplete from Copilot. It doesn't show the whole thing, but let's just see, like, it correctly inferred what the tag was, and then it also said, please check the configuration. Like, that's not unhelpful. Anyway, so that was a fix there. Yeah, you do have to pay for Copilot, but if you work in the open source space, somehow they detect that and they like give it to you for free. So I'm able to I don't have to pay for it. And I do a lot of debug or printf debugging, especially on Espressif. And so it's been really handy for like, it can also like do a decent job. Like one thing you have here, it's got a define, but it also usually is just like a const or a static const sort of thing for like setting the tag, and like it automatically inferred that. It's like good enough that it's just like super helpful. I don't have to write it all out myself. So that's been really helpful. So the gist is that on the C2, there's basically not enough memory to do Wi-Fi and BLE at the same time. I'm not going to worry too much about that. So I think what I'll do is I'll just do one final build and then I'll be done. I do want to turn, I want to switch it so the serial connection will have the baud rate. So I'm going to tweak this just a little bit. And in here, so this is how you turn on the console via a UART. And one thing that's interesting is that this board has, it doesn't have the RMT peripheral, which is short for remote, but it's also the peripheral that we use to do NeoPixel. So the C2 actually won't have NeoPixel support on it, which is a little weird. The LED that's on here, you can't see it. You know, I can move my bench cam back up. But the LED on here that is successfully blinking is a straight up RGB LED where you like PWM the RG and B separately. And that's what this is showing here. And it does work, which is neat. So I'm gonna clean, because I'm gonna switch from a debug build to a non-debug build and just see, you know, we might have enough RAM. The RAM use might be a little bit different, different enough that it might work. I should show the sample code for what I'm doing as well. But my plan after this is I'm gonna switch to the C6, because I got it working on the C6 but was having some crashes, and yeah, I got it working on the S3, and then I tried to get it working on the regular ESP32, and I was having some watchdog timeouts, which are really hard to debug. So I'll have to get back to that as well. But I thought I'd circle back to the C6 and see if I can't get the demo going completely on the C6. The product line is getting wider for me to support. One thing that I've done in this branch is I'm changing the policy, the partition layout of all new 4 megabyte boards. So what we used to do is we used to have OTA is short for over the air. And usually the way that you do that is you have 2 copies of the firmware you're running and the ability to switch between the 2. So like one firmware loads to the other one and tries to switch to it, and if it doesn't work for some reason, it can still run the original. Okay, so let's see how this does. This might be, that was buffered. Oh no, it's still on. Oh, I didn't flash it. That's why it's still outputting it. Sorry, I lost my train of thought. Oh, but we don't really show people how to do OTA yet. And on 4 megabyte flashes, we have less space for CircuitPython than we do on bigger flashes. So we do 2 megabytes on bigger flashes and 1.4 megabytes on 4 megabyte flashes. And I didn't have enough room to fit BLE, because BLE is like 200 200 or 300K. It's not small. And so what I'm doing is for existing C6s and then new C3s and new H2s, I think, and new C6s as well. I'm changing the partition scheme so it's 2 megabytes for CircuitPython, and then the user drive will actually be bigger, but OTA won't be supported. So I'm changing how that works. Let's see how we do. Okay, so what happened here is, okay, we're getting a proper memory error. So this garbage in TO is output from the device that's going at the wrong baud rate, but our serial console did get set up in CircuitPython at the correct baud rate, which is our kind of standard baud rate. So I want to leave that there, and it doesn't look like it's working, although the Wi-Fi is on, which is great. So the Wi-Fi worked, but BLE at the same time as Wi-Fi is not working. I guess now that I have, yeah, let's actually see. We'll restart and turn Wi-Fi off using the web workflow. So I don't know how we'll get it back, but what we can do is, so this is the web workflow, and I can go to the file browser, and settings.toml has my Wi-Fi password in it, and I'm just going to rename it to settings2.toml, which CircuitPython won't know what to look for. And I think what I have to do, oh, and it gave me a more specific error that time too. So that should be done. So I'm just going to hit the reset button again. And it shouldn't come up with Wi-Fi now, and I wonder, okay, so it still ran out of memory even though Wi-Fi is off. So the Wi-Fi status is up here in the status bar, and it's still off. It's probably getting further, but this chip only has 256K RAM total, and that's not a lot. So I'm not going to worry about this. I'm going to consider this basically done. So I think I'll actually do a Sublime merge and check it in as like, we have C2, like prototype C2 support, in case anybody actually uses that chip and actually wants to run CircuitPython on it. But like I said, the heap or the RAM usage is pretty tight. So let's stage that, and I marked it as alpha. Stage this, and this is ESP32 v2, so I'm gonna ignore those. I'm gonna stage this and this, and this looks right to me. That's fine. I don't care too much about it. There's lots of debug prints. I updated this macro. So this is like, here's the switch for the file system partition stuff. Tracing. Oh, this is what I want. I like this program a lot for seeing what all my changes are and kind of like picking the ones that I want to commit right now. I also want to add boards. Oh, I guess I already added it. So I'm just looking at if there's any files like this one I do want to add. I have enough junk in my yeah, I think that's what I want. So I'm gonna just commit this with basic C2 support. All right, and now let's switch gears. I'll find my, I think this is it. This is a prototype, but it's actually in the shop now. I just got it just a smidge early. This is a prototype C6 feather, and so that's what I was using for testing. And let me pull up my, it's asking for my PGP key to sign the commit. Just type in my password separately and using my password manager to do that. Okay. I don't think I'll push yet. I'll probably do one more commit here. So now I want to do make board equals Adafruit feather. I'm not going to do the ESP32 yet, like it's completing for me. I want to try the C6. And I'm just going to do a clean and a flash to make sure that I'm like in the newest version of it. And I kind of expect it to not work. It should have the test code on it already. But we'll see. I guess I should move benchcam if people actually want to see me clicking the buttons. But I kind of like have given up on the idea that it'll be merged before I go on vacation next week. But I do want to like, I was thinking about it in terms of what do I want to get done so that I don't have to like get my brain back into that context for next week. So I might actually try to get it out the door, even if it's not perfect. Like get a PR made, but not probably merged. Just to like do all the cleanup, like removing all of the prints and things. Because I'll have less context for like why I did all the changes when I get back in a week. So Foamy Guy will deep dive next week, this time. All right, our image build. See, the C6 has half a mega RAM, so 512K RAM. So we should have fewer RAM issues on the C6. But I was like literally, like it was crashing last time I tried it. So let's take another look and see how we're doing. TO dev serial, by ID, USB, and then I guess we do want the JTAG unit. That's what we're using. And then I'm gonna hit reset. And nothing appeared, but the lights are blinking like it's running. So maybe I have the wrong thing. The data cable's on. Do I have the wrong device, or do I have the settings wrong? Do I have any changes I've made? Why can't I see my board UART? So I'm not going to use the UART. Why aren't I seeing any output? This USB serial JTAG needs to be enabled, which it looks like it is. Bytes available, write substring. One thing I like to do is like to check macros, you can just add like a pound error just to see that if when you make it, it hits that code path. See, so it found that. So we are going there. I don't know why we're not getting any output on it. Like we can talk to it because we can load code. I probably disabled it some other way. So I'll have to look at what I have in my pending changes. We'll flash it again and take a look. Oh. Okay, I'm gonna hit restart again. And I save the blinks, but I don't see any output on TO again. So let's just control TQ. Let's try debug build and see if we get anything. Do 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 do. I think people will find that this is a large chunk of the behavior that they want from BLE that we didn't have on ESP. It's the server stuff. It's like used a lot when you want to pretend to be something. If you're not connecting to something, if you don't care about what you connect to, and you care about what connects to you, it's likely that you want to be a server instead. And then I could cycle back to the ESP32 as well. See if I'm in any better shape there. But man, like it was crashing really weirdly. I'm not sure why. I don't even know if it's my bug. Like it was crashing with it was safe moding with a watchdog timeout on the interrupts. So it like makes sure that interrupts aren't disabled too long, like 1.8 seconds. But like CircuitPython never directly disables interrupts. It like disables task switching, but it doesn't really disable interrupts. May the 4th be with you. Like I know we're starting up because I'm getting the right blinks. But it's weird that we're not getting any serial output. Okay. Let's go to TO again. I don't think I have any other boards plugged in. Weird. Huh. Oh, there we go. That was really weird. Now we're getting output. Code done running. It's got hello world, so it doesn't have my code. So I actually find the easiest way to load code on these now is through the web interface. And this doesn't have Wi-Fi, so unfortunately we have to say f equals open settings.toml, and I'll just show you my Wi-Fi password. I don't care. f.write. Oh, you know what I could do? I might be able to use Chrome to do this, although Chrome has been giving me problems. I'll just do it manually. f.write, and then I have a settings.toml open. It like restarted to get the output. It was very weird. Like it like disconnected and reconnected. Like maybe instead of hitting reset button, I had to like power cycle it. It wasn't something I did. It just like kind of just started working, which was very, very strange. Okay, so here's my Wi-Fi settings. I'll just paste it, it's fine. This is like the way to do it if you... Okay, I'm pasting my Wi-Fi password. I know that and I don't care. Some random number that I don't use that password for anything else. In fact, it was the default password. Paste. Okay. Oh, invalid syntax. How is there invalid syntax? Let's see. Commenting out, commenting out. Ah. Okay. And then you can actually, I was doing this on another board, you can do os.getm CircuitPy Wi-Fi SSID, and that should return it back to you. And if we hit D, now it starts up the Wi-Fi, and it should, see, somebody messed with this stuff. I'm not sure if it started up the server or not. Doesn't look like it did. I was like a little frustrated because I feel like I did the work and then somebody came along and changed it a little bit. So I think to get to the web, like it auto-connected to the Wi-Fi, but it did not auto-start the web workflow server. So I'm just gonna hit reset again. And it should start up. Disconnected and connected. And the server should be there now. Okay, so now I can I'm going to load the library this way. Actually, where I want to be. Oh, except did I select the folder one? So here you can upload a folders full. I appreciate the help anyway, DCD. Never know when I won't see it. So I changed this recently. It shows how many files are uploaded, and it also shows you disk usage, which is neat. Okay, so I've uploaded the library. And now I have 2 examples to upload. I just did this on something else. I think part of the reason I'm having to do this again is packet buffer tests and packet buffer service. And then the old way that, this is an old bundle. I think they changed it so that the files don't get munged like this. This is it has the BLE, which is like the name of the library as the start of it. Oh, and then I want, I'll just delete code.py and rename this to code.py. All right. So that was an example of me using the web workflow for something, which is really neat, I think. And now let's go back to our terminal and see where we're at. So code.running, code.py. Oh, but our code.py is running right now. We've got debug prints to say that everything started up okay. So let's use my phone. I guess I could use my computer to do this, but I tend to use my phone. So there's an app called NRF Connect here. Let's see, do you think I could do it while not looking? So I'm just gonna pull down. I don't think there's anything secret here. And then the CircuitPy one, I think that's what it says. So I'm gonna hit connect. And it tried to list. It should show all of the services here, but it isn't. And I'm not sure why. And it's this is what was happening before. It says, come on. I guess you can't see it because it's small anyway. It says connecting up here, and it's never finished. It never finishes connecting for some reason. So I'm not sure why. I don't know why that it's like connecting, but it's unable to complete connecting. And I feel like this was like something I was trying to figure out. Like, oh, I can control C it. I didn't think I'd be able to control C it. So let's just do that again. Oh, and look at that. I crashed hard. Okay, so the second time around, we had plenty of memory, but now we've crashed. We had a load access fault. And so this is on a C6, and this is something I've been thinking I need to figure out, is it doesn't dump your stack frames, it dumps your entire stack. And it's kind of a huge pain to, like, usually it'll say backtrace colon with the extensive stuff, but this is a RISC-V core. The C6 is a RISC-V core. So I think I actually want to extend, I'm going to do more stuff on this, so I think it's worth doing this exercise. So this is the complete stack. Some of these values are going to have to do with functions that have either been called immediately in our stack trace, or like kind of were in our history of stack traces. So I think what I want to do is I want to copy this, and I'm gonna make our I want to make the script I have for looking up the backtrace stuff off Extensa just kind of try to work okay with a dump like this. So I'm going to copy this, and then I'm going to go Control TQ, Python tools, decode backtrace, but I'm going to make it work with the ESP Feather 32 C6 PSRAM. And somehow I'm going to get it to handle that. Hey, look, it kind of worked, actually. It did actually kind of work just fine. I got some semblance of things, but I feel like if it's going to give me this, I should just have it skip it. Does the compiler libraries provide call stack printout? Not from the device itself. They tell you in the IDF that they tell you in the IDF that like you can recompile it with all the frame information, but I tried it and it didn't work, so I didn't look into it further. But I think like this is probably handy enough for me. Like BLE service add characteristic, and it's giving a line number. Like that's probably where we're crashing. So I think to make this script more handy, I'm just gonna say if it gets this question marks, just don't print, right? Like don't bother if it's not gonna be useful, and then it'll just condense all of the useful stuff down. So I will move this over in just a second. Here's the decode backtrace script. And this is kind of neat because it is calling the Extensa S2 ELF address to line, but it actually doesn't really matter. And if it starts with addresses, it skips it. But this one starts with stack. Oh, but like we're not even capturing the output. So we're gonna have to be a little bit fancier here. Subprocess run. I have Python 3.12 now. Capture output equals true. See, like he gave me a reasonable suggestion. And then if standard out, actually, maybe I just want, no, that's not what I want. Maybe it is what I want. That's the problem with subprocess run. It returns a completed process which has standard out in it. Result. I'm just gonna print repr of that. Sure. Yeah, it's been interesting using, so, okay, so I wanna quit this, run it again. Do I have my, no, I don't. I need my stack trace again. I should copy it somewhere, since I'm working in the same window. Stack memory. Okay. Okay. So now it's prompting me every, what is it doing? Does Espressif share source code for their SDK? So would your tool be able to show if there is an SDK function blocking and tripping the watchdog timer? Mostly. So Espressif does mostly share their SDK. A lot of it is source code in the IDF folder, but it's not all of that. There are ROM functions that you will end up calling into, and then there are also binary blobs as well. So generally it's open. For a lot of what we do, it's open, but that's not always true. So while true, subprocess run. Okay, so I'm giving it a bunch of addresses, and that's not actually what I want to do. I want to say for address in addresses. I don't want to actually print it, but that's why I'm getting this kind of weird output. This is one of my beefs, is like I have tab accept the output of Copilot, and that's kind of like not always what I want. Huh. Why is it giving me a lot of things? Oh, it's because I'm giving it addresses still. And now it knows that it's, you just want one address. There we go, that's what I want. Okay, so I want to say if this is in there, is it going to be smart? Yes, thank you. You like that? Like, is it gonna be smart? Okay, now I need my. Okay, I'm still printing the things, but it's a lot closer to what I want. I want to strip it so I don't get an extra thing, and I don't care to print that. Okay, this is split in by, yeah, we're gonna get spurious ones in here, but that's kind of okay. Although, like, we should be able to detect, like, okay, we're in some other mode. And we're still going through some prompts, which is not right. Maybe that's because we're doing input. We're assuming it's a single line. Input starts with stack memory. Hello, stack memory. Strip, split. Print addresses. For every address, run address to line. If question marks aren't in it, print it out. I'd expect addresses to be flat then. I'd really love to skip this first one. Oh, look at this. Is that from our prompt? Let's see. Like if I know what mode I'm in, then I can be a little smarter. Okay, so I am getting a bunch of individual lines. Because it is new line terminated. Darn. How do I handle that? Can the input be smarter? It reads a line from input. Problem is I'm giving it multiple lines. Maybe I don't care? Yeah, maybe I don't care. I wish that I would know load instance, map lookup, execute bytecode, add to service. I mean, this sounds really likely to me that that's our problem. So maybe what we do is we say it's good enough. Did we see our hello stack memory? Yeah, it's here. That's funny, we like start parsing it before it's actually given all of the stuff to it. I don't think it actually like super matters. Like, that's not too bad. Member lookup, bytecode, load memory. It is like in a weird order to me, but I feel like if and I wish it wasn't interlaced, but I mean, the service 132 is like super suspect. So let's ignore the fact that it's the analyzer is not perfect. It's still a lot better than not getting any sort of backtrace. So let's just in common how. So I want to fix this crash. Service 132. Add dynamic services. So this is like the last thing. So I'm going to do ESP log. And I'm like waiting to see. Let's just do that. Like I said, like for printf debugging, it's like really kind of okay. Okay, so we're gonna flash it again. So the stack dump is restricted to values that are actually on the stack and nothing beyond the either end. I don't know how it comes out. I don't know how it knows what to print. It's probably just the stack pointer to the top of this task, because it is freeRTOS. But I honestly don't know. I just know that's what it gives me. So it did work, and then we got the crash again. And we are adding characteristic 4084 to 250, 4084 7DD0. Those both look okay to me at first glance. Service definition. Let's see, let's log that as done. Okay, that wasn't as smart, but that's okay. And I actually do want to do service def. I want to print that address instead. So let's try again. This has been my week. It'd be good to fix this crash though. Could be like a, you spoke earlier about having issues running out of memory. Are you sure the heap isn't smashing the stack? I'm not sure of that. Those running out of memory issues were on the C2, but I'm on the C6 now, so I don't think that's a problem. And this is running freeRTOS, so that it should detect when the stack is smashed. I mean, should being the optimal word. Yeah, right now I'm like what I'm trying to do is basically suss out, like figure out which of the pointers is the one that's it's not working, or figure out what pointer is causing the crash. Okay, so I'm advertising. Let's just see what happens. So I'm going to do what I showed before, which is connect. And connecting is still probably going to hang, which I don't know why it's hanging. Like, it's getting this subscribe thing. But that's where it was. It was hanging, and then I hit Control D, and I hit Control D again to run, and now it crashes. It's like, it doesn't crash the first time, it crashes the second time. And it's crashing inside add dynamic services. And like these addresses look like totally reasonable. So I wonder, let's just do one more. Actually, you know what we could do? We could look at this value. This is where the crash actually happened. I'm learning my RISC-V. Adafruit Feather ESP C6 firmware ELF. This address. Nimble NPL OSH 224. NPL OS.h. I think that's what I want. 224. NPL funcs. NPL mutex pending. NPL func. So is this like if it wasn't initialized? You know, I could probably print this off. Let's copy this. Go here. Let's just print it off. ESP log. It's not going to be smart enough. NPL funcs. Ah, that's fine. See, like, I probably would have written out NPL funcs, but do I care enough? No. All right. So this is in CircuitPython code, so we can just build again. We don't have to clean. But this could be a case of like, whatever sets NPL funcs. Like I'm getting further than I should. Like I'm not initialized or something. Or maybe like Kevin's saying like it's being overwritten, which would not be good. I don't know why this, like, it doesn't show up immediately. It's annoying. This USB JTAG serial debug unit is like not. It's caused us some problems. Hey, look, NPL funcs are 0. That would do it. So this is interesting because we're not. We tore Nimble down, but we didn't start it back up again. Now, why is that? So this is just a simply like we're not turning BLE back on before we're trying to do BLE stuff. And get adapter enabled is trying to do this nimble host, nimble port stop. The task. I think we had this problem where I wonder if I can wait for the task to complete. Nimble port stop. While this task exists, I'm gonna do like a task delay. Yes. I'm gonna wait 2 milliseconds. And I'm gonna wait for it to shut down before I go on. Port stop, nimble port run done. Host task done. has not run yet. So we're like restarting too quickly. We've got to wait for it to shut down. Okay, perfect. That makes sense to me. Now it doesn't make sense to me why I'm not able to connect where it's hanging on connection. That's a separate problem. Hopefully not. Okay, let's try it. I don't know why it's so slow to come up. I guess it's connecting to Wi-Fi, which could be part of it. Control C it? No. Maybe I'm hung already. I see the safe mode blink. But not getting this logging output. Are there tools that will let you observe what is taking so long to start up? Is it BLE traffic or something internal? I mean, printf debugging. Printf debugging can do that. You probably want to go out the UART, not this funny like USB to UART thing, because I have not had a lot of success with that. Like this seems like it should work. The other thing I could do is I might have UART output. I don't have headers on this feather, but I might actually have debug UART output on the RX and TX pins. So I could add a separate UART. That's probably not a bad idea, especially because I'm having issues. So I could take a separate, where did my, yeah, I was using this for convenience. Should I set up benchcam? I'm hooking up, these aren't alligator clips, these are some sort of hook. To TX and RX. I'm going to try to get my debug output coming out of UART, which it might actually already be. And then I don't have to rely on this. I can just leave it connected and I don't have to switch back and forth or anything. It's going to be more reliable. But I got to remember how to plug it in because, you know, things can't be simple. And this is why I'm like all about plugging, not doing jumper wires. I'm not a fan of jumper wires. Oh, and my ground thing fell off. Because I haven't put headers on it. Jumper wires are a pain. Use this one. I don't remember. This is like a 2x12. And I don't remember exactly which one goes where. So we'll see if I get it right. Maybe we'll get boot ROM output then too. Okay. Waiting for the handle to be null and shut down. I think we want to continue when it's null. In the theory that after you shut down a task, freeRTOS actually will give you null back. Which I don't actually know if that's true. Like if it's completed. Okay, so does this work? Yes, it does. Oh, I got it right the first time. How nice is that? Okay, so this is the debug output now. And actually, let me split it. Let's go back to seeing what's on the JTAG port, because that is what. Okay, so we're getting both out of there, but I wonder if I can turn it off so that the UART has it, but the top one doesn't. That could be part of what's causing us issues. So let's see if we can. I need to make this bigger. Okay, let's go back to our make command, and now we can do menuconfig and console. So if you hit slash secondary console, no secondary console. I think that's what we want. So because I changed the SDK config, I'm going to go clean and flash. Then rebuild all the IDF stuff. This should help me though. This should, I feel more confident about the UART logging than I do about the USB to UART internal converter thing. But it takes a little while to build because I did the full clean. Because the kconfigs can impact code that doesn't, like the CircuitPython build system calls out to the IDF build system, but it doesn't necessarily do that based on what files changed. Like the file monitoring computation thing is not right for doing that. All right, we're gonna get C6 working. We've got 25 minutes. Let's get C6 working, and then we'll clean it all up and see where we're at, and just push it, maybe as a draft PR. That is interesting that like the task is not. Like we need to wait for the task to shut down before we consider ourselves shut down, especially because we're detecting whether it's enabled based on whether the task is still going or not. We'll take a look at that. So now we're in the bootloader, and this is why the UART output is nice. So now we can see that like the UART is getting downloaded to. Now it's staying in the bootloader, and now we hit reset, and we should get messages right from the start, which is great. So you can see here, this is like ROM bootloader output, and then second stage bootloader output here. It shows you like the partition table, the setup for the SPI flash. It's a single core. I don't think they have any dual core RISC-V stuff yet. 160 megahertz, project name, chip revision. And then it tells you what RAM it's adding to the shared dynamic memory, which is where we allocate our heaps out of. Okay, so it's advertising. So let's go back to TO and let's just Control C. And I don't know why we're green still, but it's not the end of the world. And we'll start back up, and we started back up okay. Great. So if we look at where's our reset? Start advertising. Okay, here's our stop. Port stop, port run done, port stop done. Nimble port init, start nimble task, wait for sync. What is the nimble host task done? I don't see that though. Do you think it'll work again? So I think it's still running. Where's host task done? Host task. I don't see any host task dones, which is weird. Run done, task done. Maybe it shuts it down before then? Port run done. Okay, well that seems right. Maybe it literally does stop the task before it gets to this print. Like it seems like it's working, so let's so we fixed that crash. Now let's just see what happens if we connect again. I'm gonna do what I did last time, connect, and now I'm stuck on connecting again. Like I suspect that the connecting is like I'm not running the host, like the host task is not getting called. I wish I could have freeRTOS tell me every time it's yeah, I wish it could tell me when it was switching, like if it was switching to that task at all or not. What I can do is I can, sorry, my wife just texted me and distracted me. Me texting, it's always good live streaming. Okay, so I think what I'm gonna do is I'm gonna get out of this TO and I'm gonna go back to menuconfig and I'm gonna be, there's actually a setting, what's it called? Log level. Hey, look, there's Bluetooth nimble log level. Let's just try setting that to info logs. It's gonna be another slow build. What? Sorry. I'm waiting for a compile, and it's Friday afternoon, and my wife is ranting at me. I still like infinite loops. Yeah, one's without a timeout. That's fair. Oh. Any questions? So I can get off my phone and answer questions instead while it compiles. I could also just stop streaming. All right, let's see what logging we got now. Hopefully a lot more. It failed to restore irks from store. GATT procedure initiated, extended, advertise. Okay. Let's see what it does. Connecting. And it printed nothing. It printed nothing, but it got this packet buffer event subscribe type. That's so weird. Like, it's clearly running something. Okay. Let's be even more aggressive with it. Oh, that's not the one I want. I think there is also a log level for overall. It's not this HAL one. I forget which one it is. BLE mesh. GATT. Gap trace level. Nimble log level. I don't think it's log level defaults. That's what it is. Let's bump that up too. FreeRTOS has task hook macros. Trace task switched in would allow you to print a task switch. Interesting. Okay, so let's see if that's been hooked into something in IDF land already. Thanks, HamsLab. Sager assist view. Maybe? IDF components 433. Actually, I could do freeRTOS to H. It does it to nothing. So it doesn't look like the IDF has that. At least it doesn't use it. Thank you. Yeah, I'm totally game to. All right, I think I need to wrap up. My sister just texted me too, and it doesn't make for very good streaming stuff. We'll run this and then we'll call it good. TL reset. Now we got lots of stuff. Wi-Fi scan. Whole bunch of random nimble stuff. Okay. Connect. Huh? There is more nimble stuff. But it's still connecting, and then it just switches back to Wi-Fi things. HCI ACL TX. ACL process. I don't know. I'm at a loss. None of this means anything to me. Sub-event. GATT procedure, exchange MTU. I wonder if I've got to do that myself. But that'd be so weird that MTU. One thing I could do is that I could use like an NRF and try to connect to it, and then I could see what the other end was doing. That's the problem with the phone, is that it's not telling me a lot of detail about that. All right, I'm gonna call it interrupt allocate. There's like a couple random debug statements going to the other thing too. That's weird. All right, let's call it. Thanks everybody for hanging out. Sorry I got distracted here in the last few minutes. I think I will try to get it all cleaned up and put out in a draft, just to kind of like put it out there and clean it up with context in my brain. But obviously there's work to do to get it to actually work on the C6. Like I said, I think it's working on this S3, but the S3 is also like dual core versus single core, stuff like that. And there could totally be bugs. There could definitely be bugs as well. So I'll keep poking at this when I'm back. So I'm back a week from Monday. I'm gone all next week. And I'll pick up where I left off with this. I think I will try to get it tidied up here before I go home. And I gotta get like the IDF change that I've done out there as well. Thanks, Habs Labs. If you want to support me, you can do that by supporting Adafruit at going adafruit.com, purchasing hardware there. Like some of the boards you saw today, some of them were from Espressif. But yeah, that's the business we're in. We're trying to make things like BLE accessible to folks through Python on devices. So I'll see you in 2 weeks. And thanks preemptively both to Foamy Guy for streaming next week for Deep Dive, and also to DCD, who usually takes time codes during these things. So thanks to them as well. I'll go to the window and we'll call it. All right.